This is a fairly quick review of fractions. To start out in class, we sang the fraction rap, so please reference your lyrics if you have any questions about what the fraction rap is. The top of the fraction is called the numerator, and the bottom of the fraction is called the denominator. And in case you're ever on a game show and you need to know what the fraction bar is called, it's called the vinculum. To start out, we add and subtract fractions with like denominators. So if we had 1/5 plus 3/5, our denominator stays the same. And we just add the numerators, so we get 4/5. On the second one, we have 4/5 plus 2/5, so our denominator stays the same. We add the numerators and we get 6/5. But what I notice is that the top is bigger than the bottom, so we have to ask ourselves, how many times does 5 go into 6? 5 fits into 6 one time with 1 left over, so we can reduce that down to 1 1/5. On the next one, we have a common denominator of 8, and when we add the numerators, we get 5/8. On the last one, we have a common denominator of 9. When we add the numerators, we also get 9, and 9 goes into 9 one time, so we can reduce down to 1. You'll notice these ones also have common denominators, however, they are subtraction problems, so you have to be careful to make sure that you subtract. So our common denominator is 5. When we subtract our numerators, we get 2. And the next one, our common denominator is 5, and also when we subtract the numerators, we get 2. The next one, our common denominator is 8. When we subtract, we get 1. And the last one, our common denominator is 9, and when we subtract, we get 5. As we move to the next slide, we're still talking about adding and subtracting, but what you'll notice is that our denominators are not the same. So the first thing that we want to do is we want to identify the common denominators. So between 2 and 8, we want to know where do they meet up. So if I go by multiples of 2, 2, 4, 6, 8, 10, 12, and so on, and then I come down here, I notice, I would go 8, 16, I notice that these two meet up at 8, which means my common denominator is going to be 8. So instead of writing something over 2 plus something over 8, I'm going to write something over 8 plus something over 8 equals something over 8. We need the denominators to be the same. So we have to rewrite this first fraction as something over 8. To get from 2 to 8, we had to multiply by 4, so I also have to multiply by 4 on the top. And I can put that answer, that 1 times 4, which is 4, over here. Now when I get to my second fraction, I realize it's already over 8. So I can just leave it as it is. It's as if I'm multiplying by 1, which keeps everything the same. Once you've identified that you have common denominators, you just add the numerators. So 4/8 plus 3/8 gives us 7/8. On the next problem, again, we have to find that common denominator between this time 2 and 3. So if I count by 2s, it goes 2, 4, 6, 8, 10, 12, and so on. If I count by 3s, it goes 3, 6, and I can actually stop because that is what the two share in common. We always want to find the earliest one that they share in common, or the smallest. So now I'm going to write something over 6, and this time it's a minus sign, so minus something over 6 equals something over 6. To get from 2 to 6, so I'm dealing with this first fraction, to get from 2 to 6, I have to multiply both sides by both the top and the bottom by 3. So I get 12/6. So then when I work on the second fraction, To get from 3 to 6, I had to multiply by 2. And when I multiply the top by 2, I get 4. So our new problem is 12/6 minus 4/6, which actually gives us 8/6. Now, just like on the last page, I noticed that the top is bigger than the bottom. So I have to ask myself, how many times does 6 go into 8? Well, it goes in one time, and there are 2 leftovers. We aren't actually done yet because what I notice is I can still reduce that fraction. 2 goes into 2 and 2 goes into 6. So I end up with 1 and 1/3 because 2 goes into 2 once and 2 goes into 6 3 times. So this is the correct answer in simplest form. On the next page, we're going to jump to finding the common denominators right away. The common denominator between 5 and 10 is 10. So this first fraction, we don't actually have to change because it's already over 10, but the second fraction, we'd have to multiply it by 2 to get to 10. So we end up with 1/10 plus 6/10 equals 7/10. On the second one, we have to find the common denominator between 5 and 15, which happens to be 15. So we're going to have something over 15, it's minus, it's a subtraction problem, something over 15 equals something over 15. With the first fraction, we have to multiply by 3 to get to that 15, so we have 12/15 minus, we don't have to change the second one, so we end up with 10/15. But what I notice is that this problem can be reduced. 5 can go into the top and 5 can go into the bottom. 5 goes into 10 twice. 5 goes into 15 3 times. So there is our final answer. On the third problem, the common denominator would be 8. So we would have something over 8 plus something over 8 equals something over 8. In terms of the first fraction, we'd have to multiply by 2, which would give us 6/8. And with the second fraction, we wouldn't have to change it. So we end up with 6/8 plus 2/8, which is 8/8, or 1. On the last one, the common denominator between 3 and 9 would be 9. To be careful, seeing that it's a subtraction problem. So for the first fraction, we'd have to multiply by 3, which gives us 21/9 minus, and we don't have to change the second one because we're just multiplying by 1. 21/9 minus 2/9 gives us 19/9. Now, just like the other page, the top is bigger than the bottom, so we have to ask ourselves, how many times does 9 fit into 19? 9 fits into 19 2 times, and that takes us to 18, and we have 1 left over. Now, the part of the song with multiplying and dividing fractions, we had a little phrase. The first one is, multiplying fractions, no big problem, top times top over bottom times bottom. And that's exactly what we're going to do. We're going to multiply the top times the top and the bottom times the bottom, and then we're going to make sure that we reduce. So on the first one, I'm going to do top times top, which is 3, bottom times bottom, which is 10. And this problem does not reduce, so we are done. On the second problem, we have top times top, which is 8, over bottom times bottom, which is 35. And again, this one does not reduce either, so we are done. The third problem is where we encounter a place where we have to reduce. So I'm going to show you a couple different ways. The first way is top times top gives us 6, bottom times bottom gives us 20, and then I know that 2 can go into each of these. So I'm going to divide by 2, and we end up with 3/10. Now the other way you could do is you could look to your diagonals to see if they share anything in common. When I look to this diagonal, I notice that 2 can go into 2 and into 4. So 2 goes into 2 one time, 2 goes into 4 2 times. And if I were to follow, I look at the other diagonal, nothing can be reduced. I would go 3 times 1, which ends up being 3, and 2 times 5, which ends up being 10. So no matter which way I do it, I get the same answer, and it's just a personal preference of what you would like to do. On the next one, we can do top times top and bottom times bottom and reduce at that point. 12 goes into 14 one time with 2 leftovers, and we can reduce, and we'd get 1 and 1/6. Or we can look at the beginning. 2/4 is the same as 1/2. So then if we multiplied, top times top would give us 7, bottom times bottom would give us 6, which reduces down to 1 and 1/6. So you'll notice that no matter what, we get the same answer. It's just how you prefer to do it. The next part is about dividing fractions. We say, dividing fractions easy as pie, flip the second and multiply. So students typically remember the song and they're able to repeat, flip the second and multiply, but then they get so excited about the multiplication part that they forget to flip the second fraction. So my advice to you is to always write down the flipped version with the multiplication sign in between before you move on. Then you can do top times top and bottom times bottom. So on the second one, I'm going to flip the second and multiply. Top times top, bottom times bottom, and then I can reduce. 14 goes into 20 once with 6 leftovers, and we can still reduce from there. 1 and 3/7. Now if I looked at the beginning, 5 and 7 can't be reduced, but 4 and 2 could. 2 goes into 2 once. 2 goes into 4 twice. So we'd have 2 times 5, which is 10. 7 times 1, which is 7, which reduces down to 1 and 3/7. So either way, you'll get the same answer. The next one, flip the second and multiply. We get 9/8, which equals 1 and 1/8, because 8 goes into 9 once with 1 left over. The last one, 7/3 times, we have to flip that second. Top times top is 35. Bottom times bottom is 6. 6 goes into 35 5 times, takes us to 30. We have 5 leftovers. We're going to switch modes a little bit. Now we're going to start throwing integers, so positive and negative numbers, into our fractions. So I'm going back to the basics with common denominators, adding and subtracting, and then we will build off of this. So on the first problem, our common denominator is 5, so then we have to just look at the numerators in order to figure it out. Since they're different signs, we end up subtracting. 3 minus 1 gives us 2, and there are more positives than negatives, so it stays positive. Our common denominator is 5. Since they're different signs, we subtract. 4 minus 2 takes us to 2, and there are more positives than negatives. On the next one, our common denominator is 8. So we have to look at the numerators. Since they're the same sign, we add them, and we keep that sign. And the last one, our common denominator is 9. We have different signs, so we have to subtract. 7 minus 2 is going to give us 5, and there are more negatives than positives, so it is negative. With subtracting integers, the thing that we have to keep in mind is KCF. So keep it, change it, flip it. And a lot of students forget to do that part, so I always just advise them to do it right away. So the first one, keep it, change it, flip it. 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 So then our common denominator on the first one is 5. We have -1 plus -3. They're the same sign, so we add them and we keep the sign. On the second one, our common denominator is 5. It becomes 4 plus 2, which is 6, and that reduces to 1 and 1/5. On the next problem, our common denominator is 8. We have different signs, so we have to subtract. 3 minus 2 is 1, and there are more negatives than positives, so it ends up being negative. On the next one, our common denominator is 9, and we have the same sign, so we add them and keep the sign, and -9 over 9 is -1. We're going to switch modes a little bit. Now we are going to be multiplying and dividing. And just as a little reminder, same signs give us a positive answer, and different signs give us a negative answer. So top times top would give us -3, bottom times bottom would give us 10. A negative and a negative give us a positive 8, and bottom times bottom gives us 35. Top times top gives us -6. Bottom times bottom gives us 20. We can reduce. We get -3/10. And again, you could have reduced at the beginning as well, whichever you prefer. The next one, top times top, positive and a positive, or a negative and a negative give us a positive, and then bottom times bottom gives us 12. We get 1 and 2/12, which reduces down to 1 and 1/6. Here we have some division problems, same rules as multiplication, so same signs give us a positive answer, while different signs give us a negative answer. We can't forget our rules for fractions though. Dividing fractions easy as pie, flip the second and multiply. So I had to flip the second, and top times top gives me a -5, bottom times bottom gives me a +6. And the next one we have to flip the second, and we get -20 over -14. Now, we have to remember that the fraction bar also represents division, and two negative signs with division end up being a positive. And 20 over 14 can be reduced to 10 over 7, which is 1 3/7. The next one, we have to flip the second and multiply, and we get 9 over -8. Well, we look at just the positive 8. 8 goes into 9 once with 1 left over, and we have to remember to bring this negative sign out front. The next one, we have to flip the second and multiply, which gives us -35 over -6. Again, two negatives become a positive. 6 goes into 35 5 times with 5 leftovers. Just a quick review on reducing fractions. When you're reducing fractions or simplifying fractions, you're looking for something that they share in common. So what can you take out of both of them? So for the first one, 3 goes into both. So I can divide the top and the bottom by 3, and we get 1/3. On the second one, what number goes into 2 and 4? It ends up being 2, so we can reduce, which gives us 2 over 1, which simplifies down to 2. 3 over 1 doesn't share anything in common, but it can be reduced. 3 divided by 1 is the same as just a plain 3. 7/6, since this one doesn't have anything in common, I notice that the top is bigger than the bottom. 6 goes into 7 one time with 1 left over. The next one, we're going to reduce 9 over 9. Whenever the top of the fraction is the same as the bottom, your answer is 1. 9 goes into 9 one time. On the next one, 1/2 does not share anything in common, and it cannot be reduced because 2 does not fit into 1, so you just leave it as 1/2. The third one, they don't share anything in common, but I do notice that the top is bigger than the bottom. So 3 goes into 4 once with 1 left over. The next one doesn't share anything in common, but 6 does go into 13 two times with 1 left over. One other thing that we're going to need to be able to do is we need to be able to change mixed numbers to improper fractions. So what we have to do is you take the denominator and you multiply it by the whole number, and then you add in the numerator. The denominator stays the same. So 2 times 1 is 2, plus 1 gives us 3. So 1/2 is the same thing as 3/2. The next one, we're going to multiply. 2 times 5 is 10, plus 3 is 13, and our denominator stays the same. 5 times 3 is 15, plus 4 is 19, and our denominator stays the same. 14 times 1 is 14, plus 13 gives us 27, and our denominator stays the same. Now we're going to go the other way around. So when you notice that a fraction has a bigger numerator than it does denominator, then you have to change it into a mixed number. You ask yourself, how many times does the bottom fit into the top? Well, 2 fits into 9 4 times, and that only takes us to 8, so we have 1 left over, and our denominator stays the same. And the next one, 2 fits into 16 exactly 8 times. There are 0 leftovers, which I do not have to write down, so I can just leave it as 8. 3 goes into 4 one time. That only takes us to 3, so we have 1 left over. 6 goes into 13 two times, and then that takes us to 12, so we have 1 left over. So on the next page, we're going to start bringing in mixed numbers for our addition and subtraction, keeping common denominators at this point. Right now, we're going to leave our whole number out front alone. We're just going to look at the fractional part. So 1/5 plus 3/5 gives us 4/5, and then we can bring over our whole number 1. So 1 1/5 plus 3/5 gives us 1 4/5. Again, we're going to leave these two alone, and we're just going to look at our fractions. So we have 4/5 minus 2/5, which gives us 2/5, and then I can look at my whole numbers, and 2 minus 1 is 1. So my final answer would be 1 2/5. When you start doing the problems with mixed numbers and you don't have a common denominator, the first thing that you need to do is get a common denominator. So on this first problem, my common denominator would be 12. And I'm going to bring down that whole number. The whole number isn't affected by the change in denominator. So to get to the 12, I had to multiply by 4. So I have 1 4/12 plus, I had to multiply by 3, 9/12 gives me 1 13/12. This right here is an improper fraction, and what I notice is that 12 goes into 13 one whole time with 1 left over. So what happens is, so it would be 1 and then 1 1/12. So we actually can combine the two ones, and our final answer would be 2 and 1/12. So up here, there you can add the 1 here, and then there was 1/12 left over. With the subtraction problem, we're going to first find the common denominator, which is 6. And then I can put in my whole numbers. To get to the 6, we had to multiply by 3, so we have 2 and 3/6 minus 1 and 4/6. What I notice is if I go to subtract my fractions, I would end up with a negative number because 3/6 minus 4/6 would give me a negative 1/6. So what we need to do is in our first fraction, we need to borrow. So if I borrow 1 whole, that means 1 whole of the denominator, which is 6. So instead of 2 and 3/6, I have to add 6 to the top, so I would get 1 and 9/6. And I just want to show you that comparison. So 2 and 3/6 is equivalent to 1 and 9/6, because if I change them to improper fractions, 6 times 2 is 12, plus 3 is 15. 1 times 6 is 6, plus 9 is 15. So the two of them are equivalent fractions, so it's okay that we borrow to do that. So now we have 9/6 minus 4/6, which is 5/6, and we have 1 minus 1, which is 0, so we don't have a whole number out front. So we'll go ahead and do the next ones. Our common denominator is 12. So we have to multiply by 4. We have 1 and 4/12 plus 1 and 9/12. And that ends up giving us 2 and 13/12. What we notice, or should notice, is that the numerator is bigger than the denominator, so that this could be rewritten as 1 and 1/12, but we have this additional 2 out front, so we can add the 2 and the 1, and we end up getting 3 and 1/12. On the next one, our common denominator is 10, so we have 2 and something over 10 minus 1 and something over 10. We had to multiply by 5. Here we had to multiply by 2. And what we notice is that we can't take 8/10 from 5/10. So what we're going to do is we're going to borrow, which means we're going to have to add 10 on, which gives us 15. So we have 1 and 15/10 minus 1 and 8/10, which gives us the 1 minus 1 is 0, so no whole number, and 15 minus 8 is 7. The last part that we're going to review is multiplying and dividing mixed numbers. So when you're going to multiply and divide mixed numbers, the first thing that you have to do is change anything to improper. Okay, so this one would become 4/3 times 3/4. Top times top gives us 12. Bottom times bottom gives us 12, and we end up with 1. The next one's division, so I'm going to change to improper. 2 times 2 is 4, plus 1 is 5, so we have 5/2 times, I have to flip the second. We end up getting 15/4. Well, 4 goes into 15 3 times with 3 leftovers. Here we have our last page. We have 4/3 times, I have to change this one to improper as well, 7/4. Top times top gives us 28. Bottom times bottom gives us 12. They both can be divided by 4, which gives us 7/3. 3 goes into 7 twice with 1 left over. Next one's division, but we changed to improper first. Three, 4, 5 thirds. And what a lot of students forget to do is they think of the changing to improper as a step, and then they forget to flip the second before they multiply. We get 15 tenths, which 5 can go into both of those. So we get 3 halves, which is 1 and 1/2. If you end up having any questions, please email me at hughesa@milton.k12.wi.us.